This is the final design expo poster made by the Solid Particle Erosion Senior Design 2 group for the spring of 2022. The overall objective is to build a non-invasive monitoring system for detecting solid particle erosion within a combined cycle power plant. The data communication explains how the data is first gained, then used in application toward our project. First, the piezoelectric sensor gathers the data after an impulse is sent from an impact hammer. Once read, the data will be sent to the readout equipment, which is the Arduino. The Arduino code will allow us to graph the data and then used to compare the differences of the natural frequency. The electrical circuit has multiple components, which allows the piezoelectric sensor to work with the readout equipment. All of the wires are shielded from the piezoelectric sensor to the main circuit board. The piezoelectric sensor will be powered by a 24-volt DC power supply and will later be converted into AC to be read by the readout equipment. Also, between the breadboard and the readout equipment is a voltage divider to bring the voltage from 24 volts down to 5 volts, which ensures we do not break the readout equipment. The main circuit also contains a CCD, a current regulating diode, which is used to bring the amps from the power supply down to 6 milliamps. It also contains a capacitor to reduce the voltage pulsation from the power supply. This plot shows some results from initial testing with the piezoelectric sensor in the circuit shown before. In the area of the graph where the voltage spikes, you can see that this means a large amount of vibration is being read. In the area where the voltage dips, this means that very little voltage or vibrations are being sensed. Using this difference, we will be able to compare the vibrations of a heavy object and vibrations of a light object throughout testing. The overall cost, the current one cycle cost is $3,200 to inspect the valve spindle in a combined cycle power plant. Our group's project has a one-time cost of $1,411, significantly decreasing the overall cost of monitoring this part of the system. During testing, we used 4 different spindle types, one being a standard spindle, which has a diameter of 2.25 inches, a minimally eroded spindle, which has a diameter of 2 inches, an eroded spindle, which has a diameter of 1.75 inches, and an extremely eroded spindle, which has a diameter of 1.5 inches. Future development throughout the project is to continue testing the prototype on a functioning valve, development of a custom PCB board, explore different applications of the prototype on different valve bodies, and develop wireless communication. This concludes all the parts of our final poster for Senior Design 2.